Um, all right, and so I wanted to turn it over to Patrick Connelly. Patrick, take it away.
Thank you. As was said, my name is Patrick Conley, and what we're going to talk about tonight is event monitoring, what it is and why you should care. Uh, give you a brief introduction about myself. I'm a principal software engineer at Red Hat, and I've been working on the Salesforce platform for about 14 years now as a full-time developer. I am a Salesforce MVP alum and the developer user group leader for the Raleigh Developer User Group, as well as on the board for the Southeast Dreaming Conference that is held in Atlanta every year. And that's going to be my segue to say y'all should come to Southeast Dreaming. It's going to be June 20th through the 21st in Atlanta. We've got about 41 different sessions. They're ranging from developers to admins to end users, some hands-on training, and it's going to be just a real good time. So if you like this talk, you should definitely come because I have been giving two more, one on so you wanted to be a developer and another about code hygiene and code reviews. That should be a good talk. And if you don't like this talk, don't worry. Like I said, there are about 40 other talks there, so you can just avoid mine. So let's jump straight into it and let's talk about what event monitoring is. Event monitoring is a way to take log data from Salesforce that you normally would not be able to see and download these granular, and I mean very granular details about user activity. As an example, and we'll go over the full list later if we want to see that, the types of viz you can get, log in and log out. These are URI or web clicks in Classic, Lightning data, Apex, your API calls, and way more. And this is every time somebody hits an API or makes an Apex call or runs a report or loads a dashboard, you get an entry into this file and it gives you information about how long it takes, who did it, where it spent more time in the database versus the CPU versus the total runtime, and it gives you just lots and lots of detail. The biggest caveat about it is how do you get it? If you're running a developer edition org, so you want to try out event monitoring, it's available for all the types with 1-day retention. So you can only get yesterday's logs. You cannot get any further back. If you're running the Enterprise Unlimited or Performance Edition, you get log in and log out for free with 1-day retention. And then the rest, you have to pay an extra cost to get access to all the types. This is included in what used to be called Shield, and I don't know what they've rebranded it to now, but it is part of the packaging for platform encryption and some of the other parts of the platform that have got some additional, nice kind of security things on them. So if this is something you're interested in, play around with it in Developer Edition to see kind of what data you can get, and then reach out to whomever your sales contact is to get this added. So if you want to use it, it's pretty straightforward. There's an event log file object. You query that and you're given a URI. You take that URI, you stick it on your host name for your service, and you're given a CSV file. The CSV files can be either hourly or they can be daily. And then if you have that retention, you can download up to 30 days. Each type is its own CSV file. Excuse me. So you would have to download each individual type separately, but that is nice because these files do get very large. And if you only care about like Apex, you're not running any APIs, you can get that, or you only care about logins, you can get just those files. So some of the caveats. The data can only come down in either hourly or daily granularity. You can't get the, in minute slices or half-hour slices, you only get hour or daily. And there is some delay in that data. So if at 6:01 I try to download 6 o'clock or from 5 to 6 data, it's not there. May not be there. It sometimes can take up to an hour, sometimes even longer for the quote last hour's worth of data to show up. And same with the day. At midnight, it's not necessarily going to have yesterday's data. It may be 1, 2, 3 o'clock in the morning until it's available. One of the problems is, and this may be a deal breaker for some, it may not be for others, the data comes in a CSV. There are lots of ways to take that CSV and turn it into something more useful, more data mineable, but it is in a CSV. And it is a lot of data. For example, we have about a 4,000 person org. We do hit a lot of APIs, and you'll kind of see that in some of the examples I'm going to show. But we don't have a lot of users in terms of a lot of larger orgs. And we're talking on a normal day about 4.3 gigs worth of CSV text data. For a year's worth of retention, you're looking at around a terabyte of storage just for this log data. Now, that may be fine for you if you go and stick that somewhere in Splunk and let it handle its retention. Use something that is hosted and they don't care how much data you throw at it. Go for it. But just be mindful that if you try to download everything and you have a very active org, it is a lot of data. Now, there is a thing called real-time event monitoring. The reason I don't mention this up front is because it is a significant amount of work and investment to get real-time event monitoring working. It doesn't come out of the box. You can't use the what used to be called Wave or the Einstein Analytics. You can't use that with real time. You have to use Comet D. You have to hook to those events in a pub sub model, and you have to listen to it yourself. You can take those events. There is a thing to where you can store it into big objects for up to 6 months, uh, but that has its own limitations. And not all the events are available. They are adding more and more events as each release comes about being able to access this data in real time, but not all of it is there. Uh, the reason they're doing it for is mainly for themselves because they have a thing called transaction security, which can take user behavior, intercept it, and then act on it in real time. And that is behind the scenes is using a real time event monitoring. So, for example, if you have, you could do a transaction security rule that says if somebody runs a report that returns more than 100 contacts, email an admin because who knows, that person may be trying to take all your contacts and run away to another company. Or if you get a user that's hitting the API more than a certain number of times in an hour, you can block that transaction and alert somebody. So that's what transaction security can do. That is also included in the whole Shield bundle. And that's where this real-time event monitoring is mostly useful in terms of the real usage of it. Again, you can use it if you want to stream it to somewhere like Splunk or New Relic, but you have to write that interplay. And you have to handle the replay and storage of all the data yourself. So if your service that's subscribing to Comet D goes down, you have to know where you last were to replay all the events in between, or they're just gone. And the data is still going to be large. You're still going to have a place to store it and stick it somewhere. Uh, One of the places you can stick it, and I don't know if I put a slide in here. I'm sorry if I repeat it later. Is the Einstein Analytics that does come with the event monitoring package for I say small, but a limited amount of rows that you can put into it. Uh, Depending on the size of your org that and what you're trying to put into it, that may be perfect. If you just want to look at logins or reports and you don't have a lot of them, you can push that into the Einstein Analytics and make dashboards about that, and it will automatically scrape that data and push it into Einstein Analytics for you, and you have that. Um, the new or the Splunk also has a connector that will do the pulling from Salesforce for you. I have not used that, so I don't know how effective it is. I believe it's only on a daily job, though. I don't know if they've added hourly to it yet. But that is another way. If you have a Splunk instance or you're doing hosted Splunk, you can always use that as well. There are a couple of tools to make this a little bit easier. There's one that I wrote called SFDC Event Monitoring. It's a command line tool to download and format event monitoring logs. And I'll show you some outputs of that in a little bit. But it makes it easy to be able to download CSVs or convert them to JSON and spit them out somewhere else, uh, because it takes out all of the query and fetch and authentication and everything, and it's all kind of rolled into that. Uh, the other tool that I find very helpful is TAD Viewer. Even if you never touch event monitoring after this talk or you don't ever do anything with it, TAD Viewer may become your new best friend. I use this a lot because it does great job with very large CSV files. If you've ever downloaded the login logs for your org, the 6 month or 30-day or whatever they are, CSV file of every login for every user in your org, that can be a pretty big data file. TAD Viewer will just chew through it without any problems at all. So I would recommend you take a look at that and uh, I would recommend you taking a look at that at the very least, and we'll kind of go over how it's used later. And then lastly, JQ is a command line JSON processor that you can use to take JSON and convert it using command line queries and things, and it's fantastic. Combined with the event monitoring CLI, it is a great thing. Here. Okay, I did put it in there. The Einstein Analytics. This is an example dashboard that they have on Trailhead that you can see some of the reports you can do based on. These are reports running from users, and you can create these dashboards based on the event monitoring data. So I've showed you all this stuff, but you may have noticed I haven't told you why you should care about any of this. So let's go ahead and take a look at some real world examples of how this event monitoring data might be useful. And we can kind of take a look at those. So from the Trailhead, which I have a link at the end for where these Trailhead stuff lives, but you can see this is a dashboard that they made in Einstein Analytics, and there's a huge spike around May 5th of number of logins. And if they drill down, you can see that this one user, Adam Admin, logged in 103 times in a single day. That may be abnormal. That might not be abnormal, but it is, or let me rephrase. It may be malicious. It may not be malicious. It may just be somebody had to log in a whole bunch that day. But this type of data spike is a good way to know something happened, and you can look into that. From here, you could drill into the login information for the 5th or the 4th, whichever day that happens to be landing on, and see where they're logging in. So in the login information, you have IP addresses. So you could see, oh, maybe this one IP address is coming from a country that we don't have any employees in. And that could be a pretty big red flag that these logins are trying to happen from malicious third party. Or it may be something as simple as uh, the user changed their password but forgot to update their phone's password, and their phone kept trying to log in 103 times, which is something we actually have had happen, and we're able to figure that out by looking at the event monitoring logs, because that data was in the log, and you could see that it was failing and that it was a mobile login. This here is a from actual our org. I've changed the names to protect the guilty, and it's a very quick way to see who's running an old version of the login. Recently, Salesforce has cut off older versions of logins, older versions of APIs, and this is a easy way for you to look at your data and know, oh, I need to go talk to this utility API user and tell them they need to update because 29 is getting ready to be killed, for example. this was taken before version, I think 23 or lower was removed, or whatever that cutoff was. But this is an example of stuff that you can get with event monitoring. Um, Again, this one here is real data with names changed. We had, looking at our API usage, one user in a single day that was making 2,000 API calls to an API endpoint that was for list versions. And I don't know about your company, but our company does not add versions frequently enough to require us to have 2,000 calls a day to list versions for products. So I was able to see this, reach out to that developer that was hitting this API and work with them to cache that. This went from 2,000 calls a day down to like, I think 20 a week or something like that. We talked them into just making the calls once every 2 days or once every day, and that number just absolutely plummeted. And it helped us out by relieving some of the strain on our API requests. Uh, this I did not change anything about. You can see this is a report of reports, and the interesting thing about this is you can see the runtime of this delete from your dashboard, which was the actual name of the report, was taking 12 seconds, and it was hitting 1.2 million rows. That is not an optimized report and not a very useful report, probably, especially because it's called delete from your dashboard and it was only being run once. So we were able to look at who was running that, reach out to that user's ID, or look at the user ID, reach out to them, and get them to remove that so that we were not consuming resources. Same with this case comment report. We were able to get the report of the ID, find out the user that was running it, make sure that it was correct. It's taking almost 30 seconds to run, so it's unlikely that it was actually a correct report. Uh, and we can help them optimize that report and be kind of proactive, because a lot of users aren't necessarily going to know how to optimize a report if you're allowing them to write their own. And so they can just be frustrated and be like, well, Salesforce is slow. This report takes forever to run. And it's because they're not generating their report properly. So with some kind of proactive usage of things like this, you can help give them a better end user experience by providing them by kind of cutting off some of their problems ahead of time. Again, we've got looking at look at Visual Force pages. We can see this Visual Force page here was the case view page was taking 1.7 seconds to load. We've got this case tag one, which was taking a quarter of a second to load. This negotiate entitlement view was taking half a second to load, and we can look into more, dive deeper into those to optimize those to increase the perceived speed of Salesforce by reducing the load times. I don't have any examples of Lightning things because org is not running in Lightning, but you can do similar things with the event monitoring data for Lightning. This is an example of a New Relic's dashboard that we have, where we push the data from event monitoring into New Relic Insights, and we can get data back out. And it was kind of nice to be able to see who had the most REST calls being made. We had a couple of users that shouldn't have been making REST calls, or at least shouldn't be making, 6,500 REST calls in a day, and we were able to reach out to them and again work with them to either add caching or just to not do it as frequently. And then again, we have things like visual force count and these kind of dashboards, fairly common in any log aggregator you would have like New Relic or Splunk. So we're going to take a little bit of time and look at some real data from an org, and kind of let you see what you can view with the data. Um, so this is I've gone ahead because of how large this report is. I've gone ahead and uh, pre-sorted and pre-calced it, and I'll show you the other ones in real time. You can see down here, this one is 19 or 1.9 million records, and that's pretty common for a lot of event monitoring stuff. Um, and we can see that I've got it in TAD, which is the CSV viewer. You can choose which fields to show, and you can add some pivots. So for this one, I have added a pivot on the user ID, which collapses it down based on the user ID initially. And then I added a second pivot on the entity name, and so that kind of collapses it. Or sorry, not entity name on the second pivot is on method name, so it's collapsed down to be just the queries, and then entity name. So actually, I have that reverse: entity name, then method name. So we can see this user is making a query against case comment, and in a day they are making um, 3,800 and 3,889 389,818. I swear I actually went to college and I can say numbers. Uh, Queries against the case comment object in a single day, and they have returned 5.2 million rows against them in a single day. And we can see similar things here. They've made, it appears based on this that they are making every time they make a query, they're making one against case comment, one against case escalation case, and one against our external tracker update object. Because these numbers are all almost exactly the same. So that leads me to think that they're all making the same one. And we can see here out of this, almost 400,000 queries, they don't have a single escalation case returned. So that could be a place where we could work on optimizing it with them, figure out why they're doing this, maybe talk about adding data to their case query. Since these are related objects, we might be able to talk to them to hit their API to reduce the duplicate queries to make this just one query. And if we kind of dig in a little further, this one's going to be a little bit long. We can see each individual query. If I added things like the CPU time back into it, we can see that this query here. I don't have the date time pulled up, but it took almost half a second to happen. Most of these are around, uh, you know, for 450 milliseconds. Uh, in TAD, we can also say, let's do CPU time, and we want to take an average. So now we give it a second. We can see that for all of these queries, it averages a CPU time of 25 milliseconds. So, there are things that we can do here by looking at this data to try to help optimize, to help make both the Salesforce not mad at us for hitting way too much, but also to make whatever end user of the system have a little bit better time because they are not having to wait for this data to come around. So here is another one that I have not done anything with. This is a much smaller file. It's only 6,000 rows. And this is all of our API callouts for a single day. So I was just going to show you guys how we can use TAD to view this data. So if we go ahead and take our URL here, and we want to pivot on that, now we can see what calls are being made. We got a lot of these to in contact, which is for our phone system. But let's take a look at this one specifically right here, which is uh, one for uh, let's take a look at this subscriber update. We can see if we scroll over, maybe subscriber update's not a great one. That's only got one record. This is what happens when you look at data on the fly, people. Um, so, okay, well, let's look at this people AI one. This one has happened 24 times. We can come here to our aggregations and go down to our CPU time, give us an average CPU time. an average runtime, and an average overall time. And then we can see now here, sorry, get this out of the way. Now we can see that this People AI package takes an average of 147 milliseconds. Each request takes an average of 1.8 and 1.5 seconds. We can expand that down. Why are you not expanding? Okay. I don't know why that's not expanding. But anyway, we can we would expand that the similar way that we did to the API page, and be able to see more information. And maybe we have, and I've seen this on a couple of these before. The vast majority of them are running at 147 milliseconds, but we got one that's taking like 10 seconds to run, and it's dragging uh, the average time way up. And so you could see that and see if there's any patterns in there. Now, people are kind of garbage at doing large scale data patterning. So if you want to do this in any meaningful way, I do recommend putting it into something like Splunk and being able to do trend reporting. But I do end up doing a lot of one-off reporting on event monitoring that is still helpful. You can do that, one-offs in Splunk, or for example, we recently released a new page in Salesforce, and we had some management wanted to know how often it was being used. So we could dump the event monitoring log for the Visualforce page, see how many times people were using it, and actually give a report of these specific people actually used it, and then they could take it and know which ones were not using it. This was specifically for a small subset of our support staff. There was like 15 of them that were supposed to be using this new page instead of an old one to kind of beta test it for us. And they wanted to know, were all 15 of the people actually using it? So we were able to use the event monitoring data to see the actual things. So if you want to learn a little bit more about event monitoring, there's a great Trailhead module on here, and I'll leave this up for a minute if folks wanted to write these down. And then there's a Trailhead on event monitoring analytics that is taking that event monitoring data and putting it into Einstein Analytics. And then again, there's the link there for the SFDC event monitoring package that I wrote. Before we take some questions, I'm going to just briefly show the event log file supported event types. This is on the developer docs on Salesforce, and there is a list of quite a few different event types that you can do and gather data from, and they will pretty much all have something useful in them. The only one that I have found so far that is practically useless is this logout event, because if a user's times out, so they log in and then you've got like a 3-hour timeout for their logout, it does not count that as a logout. Somebody physically has to go and click the logout button or make an API call to the logout API. So that just doesn't show up in there. So I was hoping to be able to see the average session length for a user, right? Like, this is when they logged out, and they just don't ever show up in a logout if the session times out. So just know that that's a limitation. There might be other similar ones in here. I haven't played with all of these event types, but there are quite a few of them in here. So, do we have any questions?
That was really cool. I've played around with this data a little bit, mostly the log, the what comes for free, the login and log out, data, the 1 day back, to kind of do trends on, who was accessing what. I remember there was at one point they had like a starter pack of analytics charts or something you could download as well. Do they still have that? Do you know, or is it all just kind of make your own at this point?
As far as I know, there is still the Einstein Analytics kind of pack thing that you were
Yeah,
talking about.
yeah,
We did not use it because we blew through the
yeah,
entire provided event monitoring Einstein Analytics stuff for half of a day of
yeah.
our logins.
It was pretty limited.
Um,
I agree. Yeah,
so it was less than useless for us.
yeah,
I could definitely see small orgs,
mhm,
uh, you know, that could benefit from it. Or if you already are using uh, Einstein Analytics and you have a lot more rows available, that you know could sacrifice some to event monitoring, then that might be useful. Um, but the kind of included ones, and again, it's
yeah.
been several years
It's been
since I've
several
looked
years.
at
Yeah,
what's included. They may have upped that number to be something more useful, but at the time it was not particularly useful for medium to medium large to large organizations.
yeah. It was like, oh, that's cool. You know,
Yeah.
doesn't really help, but it was cool. I really liked the the way you were able to actually use this and drill into the data itself a little more, to make more sense out of it. That was one thing that we were really lacking at the time when we were investigating, doing Shield and at the time, and being able to access all this additional data is what do we use to parse it with. And we were looking at Einstein, and it was it wasn't at the time, it wasn't able to support it. So it's cool that it's cool that they've added some additional stuff for this, and some additional tools like Splunk and stuff for this. So
Yeah. And it does look like Splunk now supports the real time events into their dashboards and stuff. So that's pretty good.
mhm.
Um, so if like most large organizations I have found have some kind of Splunk capability, I would again, depending on your org and depending on how they're paying for Splunk logs, uh, it might be better to ask for permission than beg for forgiveness on just
Yeah.
dumping all of it in there, because it can be a lot. You can, once you get it, one of the fields in the uh, event log, event file log, right here. One of the fields you can do is log size, and it'll
Hmm.
tell you the number of bytes that the CSV file is. So you can kind of get an idea of, oh, over the past month or past week, what size of the CSVs are in raw text data, and kind of give you that idea if you need to pass that on to a Splunk admin or something to let them know how much data you're going to be using.
Any other questions or comments from anyone else on the call? Okay, well, I will take that as a no. Well, thank you, Patrick. I appreciate your time. This was a really interesting topic. I really appreciated it. It's always great to see tools that Salesforce has brought out a few years ago, and how they've continued to expand them, and really make use out of them. So this was really cool. I appreciate your time.
Yep, glad to be here.
Okay, and with that, I will go ahead and end the meeting. Have a great rest of your evening, everyone, and take care. Thank you.
Good night, everyone.
Good night.